Look up on a clear night and you will see maybe a few thousand stars. That's it. A few thousand out of hundreds of billions in this galaxy alone. And this galaxy is one of trillions. Somewhere out there, the numbers say, someone should be looking back. But nobody is. As far as you can tell, you are utterly, completely alone. This is the Fermi Paradox. And the real answer is far stranger than you think. In 1950, a physicist named Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. The conversation drifted, as lunch conversations do, to flying saucers and aliens. Fermi listened, did some rough math in his head, and then asked a simple question that has haunted scientists ever since. Where is everybody? It sounds almost naive, but the more you sit with it, the stranger it gets. Your galaxy is about 13.6 billion years old. Your sun is a relatively young star, only about 4.6 billion years old. That means there has been time, an enormous amount of time, for other stars to form planets, for life to emerge on those planets, and for that life to evolve into something intelligent, something capable of building ships and sending signals. Even at achingly slow travel speeds, a civilization with basic rocket technology could colonize an entire galaxy in something like 5 to 50 million years. That sounds long, but your galaxy has existed for over 13 billion years. 50 million years is a rounding error. If even one civilization had started spreading a mere 500 million years ago, it should have reached every corner of the galaxy by now, including your little corner of it. So where are the ships? Where are the signals? Where is everybody? To understand how serious this question is, you need to understand just how many chances the universe has had. In 1961, an astronomer named Frank Drake wrote down an equation to estimate how many communicating civilizations might exist in the galaxy right now. It multiplies together things like the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, and the fraction of life that becomes intelligent and starts broadcasting into space. Nobody agrees on the exact numbers to plug in. Some come out pessimistic, suggesting you might be the only one. Others come out wildly optimistic, suggesting the galaxy should be teeming with civilizations. But here's the part that should unsettle you. Even the pessimistic estimates, the ones that assume intelligent life is incredibly rare, still tend to predict that something should be out there. And you have been listening. Since the 1960s, radio telescopes around the world, including efforts run by the SETI Institute, have scanned the sky for artificial signals. NASA's Kepler Space Telescope alone confirmed the existence of thousands of exoplanets, planets orbiting other stars, many of them sitting in the so-called habitable zone, where liquid water could exist on the surface. The ingredients for life, it turns out, are common. Rocky planets are common. Water is common. And still, silence. This is where the paradox stops being a fun thought experiment and starts being a genuine problem in astrobiology. If the ingredients are common and the timescales are enormous, the absence of any evidence at all becomes its own kind of evidence. Something is filtering civilizations out. The only real debate is what and when. This idea has a name. It's called the Great Filter, and it might be the most unsettling part of the entire paradox. The Great Filter is some barrier, some improbable step that prevents matter from turning into a galaxy-spanning civilization. The question you have to ask yourself is simple and a little frightening. Is the filter behind you, or is it ahead of you? If the filter is behind you, it means the hard part has already happened. Maybe the jump from simple chemistry to self-replicating life is astronomically unlikely, a fluke that happened once on Earth and almost never anywhere else. Maybe the jump from simple single-celled life to complex multicellular life, a transition that took roughly 2 billion years on Earth, is the rare step. If that's the case, you are rare, you are precious, and the silence out there is not a warning. It's just evidence that you already beat the odds. But if the filter is ahead of you, that's a different story entirely. That would mean civilizations reach roughly your stage of development, industrial, technological, capable of sending signals into space, and then something stops them. Every time, without exception. Nobody knows what that something would be. Maybe it's something environmental, a species that inevitably strains its own planet past the point of recovery. Maybe it's something technological, a threshold where the tools capable of building starships are also, unavoidably, capable of ending everything. Maybe artificial intelligence outpaces biological intelligence, and civilizations simply stop being biological before they stop being interesting. Nobody knows. That's the terrifying part. If the filter is ahead of you, you would have no way of seeing it coming, because nobody who has hit it has ever survived to send a warning. There is a third option, one that gets less attention but deserves just as much thought. Maybe there is no filter at all. Maybe civilizations are out there, plenty of them, and they are simply not detectable the way you are looking for them. Some scientists call this the zoo hypothesis. The idea is uncomfortable, almost insulting. It suggests that advanced civilizations know you exist, have known for a long time, and have deliberately chosen not to make contact. Maybe they're watching from a careful distance, the way a conservationist watches an isolated ecosystem, worried that any interference would permanently change what they're observing. Maybe there's an unspoken rule among civilizations far older than yours. You don't introduce yourself to a species until it's ready. And by every measure that matters, a species still arguing over its own borders might not be ready yet. There's an even darker version of this idea, one that reframes the silence as something closer to a survival strategy than an accident. If the universe is vast and resources are finite, then broadcasting your location to everyone who might be listening could be less like sending a friendly greeting and more like lighting a signal fire in unknown territory. Under that reasoning, every civilization that survives long enough to think clearly eventually learns the same lesson: stay quiet. If that's true, the silence you hear isn't evidence of emptiness. It's evidence of caution, playing out across an entire galaxy, from civilizations who understood something you haven't learned yet. Consider how young your own radio signals are. Humans have only been broadcasting detectable radio waves for about a century. On a galactic timescale, that is an instant. Any signal you sent decades ago has traveled, at most, a few dozen light years into a galaxy that is over 100,000 light years across. You have barely whispered, and you are already frustrated that nobody has whispered back. And what if advanced civilizations simply move past radio? Your own species used radio for less than a century before starting to shift toward more efficient, tightly targeted communication methods that would be nearly impossible to detect from a distance. A civilization only slightly more advanced than yours might be silent, not because it doesn't exist, but because it has already outgrown the very technology you are using to search for it. There's also the simplest, strangest possibility of all. Maybe distance itself is the answer. The observable universe is almost incomprehensibly large. Even within just the Milky Way, the sheer scale of space means that two civilizations could exist at the same time and still never have any realistic chance of detecting each other, separated by tens of thousands of light years and message delays that would outlast entire empires. There's also a possibility that has nothing to do with hiding or filtering at all. Maybe you are simply early. The universe is roughly 13.8 billion years old, but it will keep making stars for trillions of years to come, long after your sun has burned out. Red dwarf stars, the small, dim, slow-burning stars that make up the majority of stars in the galaxy, can live for trillions of years, far longer than a star like your sun ever will. If intelligent life needs a truly old, stable star system to fully develop, then the era of galaxy-spanning civilizations may not have even started yet. You wouldn't be late to the party. You would be one of the first guests to arrive, wondering why nobody else has shown up, without realizing the party hasn't really begun. So which is it? Are you early? Are you rare? Is the filter behind you or ahead of you? Nobody can say for certain? Not yet. But here's the strange part, the part worth sitting with. Every single night, when you look up at that scattering of a few thousand visible stars, you are looking at a tiny, tiny fraction of the roughly 100 to 400 billion stars in this galaxy. Each one is a candidate. Each one might have planets. Each one is a question mark in an equation nobody has finished solving. You are living inside an open case file. Voyager 1, the farthest human-made object from Earth, carries a golden record on board, etched with sounds and images of your world, sent out just in case someone, someday, finds it and wonders who made it. It's a message in a bottle thrown into an ocean so large that someday might mean millions of years, if it means anything at all. Maybe that message will drift forever, untouched. Maybe it already has company out there that you simply haven't found yet. Maybe you are the first ones to ask the question at all. The next time you're outside on a clear night, take a moment before you go back inside. Look up, pick one star. Just one, out of the few thousand you can actually see, out of the hundreds of billions you can't. Ask yourself the same question Fermi asked over a lunch conversation more than 70 years ago. Where is everybody? Maybe the silence isn't empty. Maybe it's just early.